So today we're going to talk about something called a power series, and technically you've already done this a little bit. You just don't realize it. So remember how, very first thing in section 11.2, this is just like a review example you can either watch or write down. I said I wanted you to find the x such that something like the sum from n equals 0 to infinity x over 5 to the n converges. Does that ring a little bit of a bell? Okay, and so how did you do this one? Yeah, so, specifically, what kind of series is this? Because you're on the right track. This is a geometric series, right? So this series is geometric. What's the a and what's the r? A is 1. R is x over 5. Do you guys buy that? And this series will converge if, is it just x over 5 is less than 1? Absolute value of that thing is less than 1. Which is the same thing as saying absolute value of x is less than 5, right? Just multiplying the 5 over. Or it's saying x is in between what two numbers? Negative 5 on the lower end and 5 on the upper end, right? Okay. We're going to do this today, except for we're going to look at more general series that are not just geometric. Does that idea make sense? Like we'll use things like the ratio. We're going to use the ratio test a lot today, the ratio and the root test. Okay. So if x is a variable, then a series of this form is called a power series. So you see how this is kind of like a generalized polynomial? Do you know what I mean by that? Like a polynomial is numbers times x, is like things with x's to whole number powers added together, right? A polynomial would be if you just had a finite sum. Does that make sense? Whereas this is an infinite sum, and in that case it's called a power series. And these numbers, the a0, a1, a2, a3, those are just constants that are determined by this formula up here. Okay? Now, more generally, you can write these power series also like this. And instead of it just being x raised to a power, now it's x minus c raised to a power. And we're going to use this in section 11.10 and 11.11 to approximate functions. And this thing is going to estimate a function near a point where x equals c. So this might estimate something. And in this case, what is the value of c that kind of got plugged in there and then disappeared? This is kind of the case where c was equal to 0. Because if c is equal to 0, this just becomes x, right? This becomes x to the second, right? Etc. And this is like how you calculate. If you punch in like sine of 522 radians, this is probably how it figures it out. It's some formula like this, where it like ends at like the first 10 terms or something like that. And it centers it around the thing you're looking at. So we'll talk about how to find stuff like that in the later sections. Okay, so this one is just a really easy example. Tell me where the following power series are centered, and let's also add to that and tell me what the a sub n thing is. Like there's a formula for it. So this first one, where is it centered? Someone said it, I just say it loud and proud. C equals 0. Okay. And what's the a sub n? N factorial. Yep, a sub n is the thing that's in front of the x to the power. So you kind of have a combination of x's to powers and then stuff like we had last time.
Is this a new thing?
Nope, we should have note packet already. Where is this one centered?
4.
That's c equals 4. And what's the a sub n thing? 1 over n to the 5th, exactly. So it's kind of like you have the x part and then you have the other part of it, right? where's this one centered?
-5.
And then the a sub n thing is 1 over 2n factorial. And it's kind of related to the center of a circle in some sense. Like if I gave you x plus 1 squared plus y minus 3 squared equals 25, where's the center of this circle? -1, 3, right? See how it's also got that kind of opposite thing going on? Okay. Alrighty.
It's not the hardest thing to pick up.
No, that was not the hardest thing to pick up. It's an okay day to walk in 5 minutes late. So a power series in X can be viewed as a function of X, and the domain of this function is all the X for which the power series converges. Because if it would make no sense for it to include numbers with a power series diverge because of your function like equaling infinity. Does that make sense? So it's this function, it's a function, you can plug in x's and get out values, but its domain is all the x's for which it converges. Does that kind of idea make sense? With the previous one that we had, the one from like way back when, n equals 0 to infinity, was at x over 5 to the n, right? I would call that a function. What would its domain be?
All numbers less than 5?
Almost.
-5.
-5 to 5. All numbers less than 5 down to -5.
Oh, okay.
Does that make sense? You can't go too negative or your r also gets too negatively big. Does that make sense?
I was thinking an absolute value, I'm sorry.
Exactly. Yep. You could have also said absolute value of x less than 5 is the domain. Like that's an equivalent statement. Yep. Why would it be? Well, the domain is all the x for which the series converges. Like the x's you can plug in and get a converging series. So could you plug in 10? If you plugged in 10 for x, would you get something that converges? You see that? So the domain is all the x's for which it converges. That's why this one's between -5 and 5. Okay. So for a given power series, you have one of the following 3 possibilities. The series converges only at one value. And so why is x equals c always going to work? What happens when you plug this guy into there? You get a whole bunch of zeros. Does that make sense? This becomes the sum from n equals 0 to infinity, a sub n times 0 to the n, which ends up just being 0 no matter what, right?
Well, if you plugged in infinity, it'd be weird.
Yeah, but the thing is that one option is this power series will always converge when x is equal to c. It'll always converge at its center.
Yeah.
And in that case, like giving an interval of the set of values for which your series converges would just be like the number c and that's it, which is a point, converges at one point. And in this case, well, we'll go back to that last bit in a second. It could converge for all x. Like that means no matter what x you plug in, you're going to get a convergent thing.
Would that be like 1 over n to the x?
We'll have examples, okay? So negative infinity to infinity would be the set of all values for which that converges. That's like all x's. And the last case, I made a typo. It should say there is a positive number r such that the series converges if x minus c is less than r and diverges if x minus c is bigger than r. So for example, on the one I did before, we had convergence if the absolute value of x was less than 5, right? Which is kind of like saying my center is 0, and between -5 and +5 I'm okay, but outside of that I'm not. So the picture for this guy, what happens is your center moves. There's your C. and you converge up to and maybe or maybe not including those endpoints. It just depends. But everything in the middle you converge plus or minus R. This one was just 0 plus or minus 5, right? This one is C plus or minus that number. Do you see how, okay, and then that radius, this thing that's called R, this R is called the radius of convergence, which kind of refers to how wide your interval is, like how long it is. So in this case, right here, the radius of convergence would have been 5. And this is kind of like a one-dimensional circle. It's like you have your center point 0, and you go around a distance of 5 away from 0 on both sides. Kind of like if you look at a regular circle, if its radius is 5, what is its diameter? 10. This thing has a radius of 5, what's its diameter? 10. If that number had been 10, from end to end would have been 20 wide. So it kind of is the same thing as you have a center point and you go on either side of it in both directions, the same distance. Kind of like a circle is the same idea, just two-dimensional. Okay, so if radius refers to how wide your interval is, for the first case, how wide is an interval that contains only one value?
0.5.
How wide from end to end? Let's do the next one. If your interval contains negative infinity to infinity, how wide is that interval?
Infinity.
It's infinite. So in this case, you'd say R is infinity. If I just had a single dot, does a dot have width? No. Your radius is 0. It includes that number and nothing to the sides of it. So if you think about this radius as being how wide is my interval, then I think the 0 and infinity thing should make sense, right? Okay. So, and then this interval from end to end, there, that's called the interval of convergence. So I think we should try an example, and then it might make a lot of sense. So radius and interval of convergence for this guy. So n equals 1 to infinity, x minus 5 to the n over n. So is this series geometric? Could we have used that whole geometric argument on this guy? No, it's not. But it's close, but it's close but so not close at all? What messes up the geometricness? The n, right? A geometric series is a number times something to the n, right? That n messes with it. And even if you have a geometric series, what we're going to do next will always work. So the first thing you should do is apply the ratio test. So step 1, let's apply the ratio test. And just see what comes out, okay?
For convergence.
Mm-hmm. Our a sub n is x minus 5 to the n over n. And we'll get some kind of expression out, and maybe that expression can help us tell where this series is going to converge. Okay. So when you plug in n plus 1, what do you get?
X minus 5 to the n plus 1.
Mm-hmm. Over
Plus 1.
and plus 1, great, times n over x minus 5 to the n. Does that make sense? Okay, a bunch of stuff something should cancel. What cancels?
X minus 5 at the end.
X minus 5 to the n. So I have x minus 5 times n over n plus 1, still all absolute value, just for now.
Well, there's a chance you could get a negative.
Yeah, so can the n's be negative? No. Could the x be a negative number, though?
Yes.
So what we can do now is at this stage, we can break this into limit n goes to infinity, absolute value x minus 5 times n over n plus 1. There's no guarantee the x minus 5 isn't negative, but the n's are certainly not. And here's the thing, x is some fixed number, so the limit is just telling you what happens to n, right? So this x minus 5 is kind of like a constant, and you can ignore it or factor it out of the limit. So as n goes to infinity, this thing goes to x minus 5 times whatever n over n plus 1 goes to, which is 1. Does that make sense?
Is it?
Mm-hmm, it is.
I
Yep.
thought infinity over infinity wasn't necessarily.
Well, in this case, it is. You could L'Hopital's rule it to prove it to yourself, or if, they have the same power, same degree.
No, I get it, but
Yeah. In this case, it is, though. Okay, so that limit is x minus 5. Absolute valued. Okay. So we know this converges if absolute value of x minus 5 is less than what number? 1. Where did that 1 come from?
the n over n plus 1 thing.
Nope, not that. When do you have convergence with the ratio test? Like, if you do the ratio test, this is what you're going to get at, right? Your convergence with the ratio test, your thing is less than 1, right? Now look, this is the whole x minus c is less than a number, right? This tells you that your radius of convergence, r, is equal to 1. So put a box around that. So the stage at which you have x minus c less than some number, that number that your x minus some number is less than is your radius of convergence. I can also explain at the end how you can think about that as being a width, okay? Yeah?
So for every ratio test, R is going to be equal to 1?
No, because some ratio tests, what's going to happen at this stage is you'll get like x minus 5 over 3. And then we'll have examples where it's not 1 for sure, okay? But for this one, it is 1. Okay. Is everyone okay with whole, this is like of the right form kind of business to give you the R?
Wait, why is 1? I missed why is 1?
This is 1 because of the ratio test, right?
Yes, okay.
Okay.
Got it.
And then it's of this x minus a number less than some other number. Therefore, that number is your R.
So how do you find the actual range?
Oh, great question. How do you find the actual range? Okay, so then, do you agree that x minus 5 being less than 1 is the same thing as it being in between -1 and 1? Do you buy that? Okay, and then solve that for x. By adding 5 to every side, right? So you get x is in between what and what?
4 and 6.
Mm-hmm. Okay, and look at how wide is that interval from end to end?
2.
2. That's kind of like the diameter of the interval. The diameter of the interval is 2, and that's
2 times radius.
2 times the radius, okay? Okay, now this is almost your interval of convergence.
Of course it's not.
Well, there's a reason why.
Because math.
Nope, okay, well, yes, because math, but, okay, because the interval of convergence is all the x's for which your series converges. We know it converges for between 4 and 6. The question is, what happens at 4 and at 6 exactly? Okay, and the reason that those points are tricky is that if x is equal to 4, what number do you get when you plug 4 into this thing? 1, and the ratio test is inconclusive when your result equals 1, right? When you plug in 6, what do you get in this x minus 5? You get 1, which is inconclusive. So now what you do is you just take these numbers, 4 and 6, and plug them in for x in your original series. Okay? So like, I mean, look at x equals 4. So at x equals 4, you get the series is n equal 1 to infinity. So plug 4 in for x. What is 4 minus 5?
Negative.
-1. So you have -1 to the n over n.
That's an alternating series.
This is an alternating series with b sub n equal to 1 over n, right?
Which is inconclusive.
Whoa, which actually is convergent, right? Because
I thought 1 over n was not convergent.
It's very easy.
that's equal to 0, right? And is bn plus 1 less than bn? Yeah, 1 over n plus 1 is less than 1 over n, right? So this guy, at x equals 4, we have converges. Okay, by the AST. And these should be really easy to see, so just give me like a really quick, like, yes, I did my AST check, okay? How about at x equals 6? When you plug in x equals 6, what do you get? Tell me the series, and then you do have the right conclusion, but just tell me what you get.
Why would it diverge to be 1 over n?
You get 1 to the n over n.
Which is 1 over n.
Uh-huh. And you were just telling me,
Divergent.
which is divergent, yep.
I don't know what I was thinking of.
Diverges. And give me a quick, why. You could say harmonic or p-series. So the interval of convergence, I'm going to abbreviate IOC because it's just so, long to write, is, so you include 4 and don't include 6. Either write it like this, with inequalities, or in interval notation, it's 4 comma 6 with a bracket and parenthesis, exactly.
I like that one better. A lot less space.
Yeah, either one is good. So you use the ratio test or the root test to get like a bulk of your interval, and then you plug in the endpoints to see what happens there.
I'm sure you could use calculus on interviews.
Yes, you can use calculus in interviews too. So Mary Kay had a great question about okay, is the radius always going to be 1? And the next example is the case where it's not, okay? So it'll be more obvious there. Okay, this one technically is geometric, and you could use that, but let's do the ratio test just to practice, okay?
Yeah.
You could also do, you want to do the root test because it's more fun? Sure, we'll do the root test. Okay, limit n goes to infinity, nth root, absolute value an, and our an is x plus 2 to the n over 5 to the n. Okay, nth root, value x plus 2 to the n over 5 to the n.
Why does x plus 2 over 5 to the n?
Yeah, do you guys agree you just get, well, actually, you get absolute value x plus 2 over 5, right? Do you agree with that? Because the nth root goes away.
Well, either way.
Yeah, exactly. Okay, now this is a little bit weird, but related question. If I give you the limit as n went to infinity of 5, what's that limit? 5, right? I think it's a horizontal line, right? So what's the limit of this thing right here? X plus 2 over 5, exactly.
Assuming
It's a constant, right? It's just some constant. The limit of a constant is just, think horizontal line that's flat. Okay, so this will converge if the absolute value of x plus 2 over 5 is less than what number? 1. And to find your radius of convergence, you can't have any constants here. Like that over 5 thing kind of messes with it, so you multiply the 5 over to this side. and you get the absolute value of x plus 2 is less than 5, and at that stage, you can say what your radius is. So what's the radius now? R is equal to 5. It's always equal to this number, but as long as you have this thing written in the form x plus or minus something. Okay, once you got that, that's your radius. By the way, where's your center? -2. Does that make sense? Okay. So now make that into an interval. The absolute value of x plus 2 being less than 5 means x plus 2 is in between what two numbers? 5 on the upper end and -5 on the lower end. Which implies x is in between -7 and 3, right? What is the diameter of this interval from end to end? It's 10 spaces, right? Which is, you should always get something here that is twice that number there. Okay? That's always going to happen. Okay, and now you know that the power series converges for everybody in the middle, but just got to check the 3 specifically and check -7 specifically. Okay? And I'm not withholding any like hard and fast rules, I swear. Okay? Like there is no, you have to just check. Like there's no shortcut. I'm not telling you now. Like I'm not lying.
Does that become like 9 to the end?
Yeah, well, -7. What do you end up with?
-1 to the end?
You end up with -5 to the n over 5 to the n, right? Which is the same thing as the sum from n equals 0 to infinity of -1 to the n. Does that make sense? At least that's what you get, right? So does this thing converge or diverge? Think about what happens to its terms as it goes to it alternates, but do the terms go to 0? No. So this thing technically diverges by the test for divergence. And the reason is the limit as n goes to infinity of -1 to the n does not exist because this is continuously oscillating between positive and -1. It flip-flops, right? At x equals 3, it's even more obvious.
It's 5 over 5.
You get 5 to the n over 5 to the n. So what does that simplify to?
1.
Uh-huh.
I don't remember if that converges or not.
Well, think, this is like adding 1 to itself an infinite number of times.
Okay, yeah, you're right.
Yeah, so this thing
Diverge.
diverges.
I thought that was 1.
So your interval of convergence is either this interval notation or -7 less than x less than 3.
So is it 1 to the n?
It's 1 to the n,
It is.
but 1 to the n is just 1. Does that make sense? Because 1 to any power is still 1. I just got lazy and left it off. So any combination of endpoint convergence is possible. Like you could have neither endpoints converge. You could have one of the two converge, or you could have both of them converge, okay? Like it can go either direction. So there's no like, it's always this way or it's always that way.
Do you ever get an all real numbers one?
Yeah, we'll have some of those. Because they look a little strange, but it's good to have a few of them. Okay, this one is not on your notes, right? I think I took it off. Yes? Tell me it's gone, 'cause I'm not prepared about it. Ha. This one is next, right?
That one has to diverge.
Okay, so find the radius and interval of convergence for this guy. N factorial times x to the n. Holy moly, okay. So our a sub n is n factorial x to the n. We're going to apply the ratio test. All right, so when you plug in n plus 1, into that thing, what do you get?
1 plus 1 factorial.
Mm-hmm. Times x to the,
1 plus 1.
and then this one isn't a, we can just put, you know, an on the bottom because the thing we're working with wasn't already a ratio. So what's a sub n equal to?
Factorial,
Mhm.
that's x.
Mm-hmm. Good. All right. What does n plus 1 factorial over n factorial cancel out to?
M plus 1.
N plus 1. And that can come out of the absolute value bars because n's positive, right? What else is left there? Mm-hmm. And that's still an absolute value bars, right? Okay. So no matter what number x is, where's this limit going to go?
Infinity.
Infinity. Is infinity ever less than 1? Actually, no, not your question. No, actually, is infinity ever less than 1?
When x is 0.
Only when x is 0, yeah. Only when x equals 0.
I thought 0 times infinity was not necessary.
Well, it's because what you do is you put 0 in initially, and so this 0 kills us off before you take the limit. It's kind of like a PEMDAS thing.
Oh.
You see what I'm saying? Like you do all this stuff inside, and then you take the limit.
So as n goes to infinity, is there?
It's just a bunch of, it's just, there's no n there at all, exactly. So this converges only when x equals 0. See, that was that, notice how 0 is the center of this guy, right? Yeah.
Oh, isn't there supposed to be an n involved? Like, the x plus 1 goes away, but the n is in the denominator?
Because I have n plus 1 factorial over n factorial. N plus 1 factorial is n plus 1, and then n factorial, because it's like n plus, and then the bottom also completely cancels away.
I was going for it.
Okay, yeah. Okay, so only when x equals 0, that means your radius of convergence, how wide is your interval? 0, because it's not wide. And the interval of convergence is just that one number for which the series converges. Is just 0, or you could just say x equals 0 only. That's okay, either don't care. Just tell me somehow that you know that this series only converges at its center. Only converges at its, and that one doesn't have an apostrophe. Converges at center value. So this will, if you see, if you work out a problem and you get the limit being infinite, it's always the case that the radius is 0. Does that make sense? If this limit comes up to be infinity, this is not less than 1, right? Which means you have divergence, except for the case that you're at your center. Otherwise, you're diverging. Now the question is a little bit, what does the other one look like? Does that make sense? Because you also could have the radius of convergence being all real numbers, kind of like opposite things, either one number or everything. Here's an example of everything.
Because no matter how big the top gets, the bottom's bigger.
Mm-hmm. So our an is -1 to the n, x to the 2n, 2 to the 2n, oh shush, n factorial squared. It's not that bad.
An alternating series.
It is, but we can't apply the AST because you see how we've x's and n's?
So instead we have to
Do the ratio test, yep. Okay. So when you input n plus 1 on this one, just be careful to use parentheses. Does that make sense? So you have -1 to the n plus 1, x to the 2 parenthesis n plus 1, 2 to the 2 parenthesis n plus 1, and then n plus 1 factorial squared. 2 to the 2n n factorial squared negative 1 to the n x to the 2n.
So will that leave us in x squared?
Yes, it would. Do the negative ones matter?
No.
So can I quit writing them? Okay, so I'll just also show you some more work. X to the 2n plus 2, 2 to the 2n, n factorial, over 2 to the 2n plus 2, n plus 1 factorial, n plus 1 factorial, over x to the 2n. So all I did there was distribute my 2's and write the squareds as something times itself.
So we're left with n plus 1 squared.
So now think about what's left in various places, and I'll try to color code it so you can see it more easily. I see what's sort of canceling what. So first I have this x to the 2n plus 2, and then I have this x to the 2n in the bottom, right? What's that going to cancel out to?
X squared.
X squared, and where will it be, top or bottom? Top, okay. Then I have 2 to the 2n, and 2 to the 2n plus 2, that's going to be 4, and it's going to be in the, good job. And then how about the whole factorial businesses?
N plus 1 squared.
N plus 1 squared, and it's going to be in the bottom. Okay. All right, so what's...
We're assuming x squared is supposed to be a constant for this purpose.
X squared is a constant for this purpose, yes. So you really have like a constant divided by 4 times something with n's in it. So where does this thing go?
0.
0. So this limit is equal to 0 no matter what x is, right? How does 0 relate to 1?
Less than 1.
This is less than 1 no matter what.
Always.
Yep, exactly. Slash. This is always less than 1. And that always means for any x value, as in like whatever x you pick. If you were to like do the ratio test and blah, 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 you'd get 0 every single freaking time. So that means the radius of convergence is infinity. And the interval of values for which this converges is negative infinity to infinity,
Non-inclusive.
or all real numbers. You never include, infinities always get parentheses in like this notation. Or that R symbol, which means all real numbers. I think it's not super bad, right? I mean, it's just doing the ratio test a bunch of times, right? And then often what happens at the endpoints when you have them is you have an application of the alternating series test on one end and some kind of p-series on the other. It's a common thing. So, or you have 2 geometric series maybe. Okay. So how about you try this one, because it's really not any different. Like just try to do the ratio test and see what happens. See if you can get it.
You have exponentials over a linear.
Yep, and it's kind of like one of the first ones we did. So just give it a shot.
This would be the ratio.
This will be the ratio test, yep. So give the ratio test a try.
I'm not supposed to get negative things.
Nope. I'll start writing now, so if you want to like check your work against mine, you can.
Oh, the absolute value kills the negative ones.
Mm-hmm. So did anybody get x minus 1 when they did the ratio test? Did you get that far? Okay.
Yeah, I see how that would be.
See how that works?
But my x minus 1 was in the denominator.
It shouldn't have been. If it is, you made a mistake, because the ratio test does the n plus first term over the nth term, right?
I know what mistake I made. I did the original times.
You did,
the
you reciprocated, you did the original times the n plus first, yep.
Yeah.
Yep. Okay.
So basically the opposite of what I got.
Yes.
You separate x minus 1 out, you can put it outside the limit, right?
Yes, you can, yep.
Alright, so then you get 1/2 on the inside of the limit?
Oh, no, you wouldn't. You're looking at the wrong numbers. So what you're saying is you want to take the x minus 1 out of the limit, right?
Yes.
Okay, totally fine. Because it's like a constant, so it can factor out. Then the question is, in that limit, which is the part that's sort of important in making the limit go to a specific number? It's the n's that matter, not the 1. So what you could think about at this stage, you can do one of two things. You can use L'Hopital's rule. You can differentiate the top and differentiate the bottom.
Well, it's
1
1.
over 1. Or the other way to do it with algebra is that you could multiply by 1 over n and 1 over n. So that would make it 1 plus 1 over n and 1 plus 2 over n. So with these limits, the most important thing is the highest power. Everything else is irrelevant. Maybe really, you take a big number and you add 1, big number and add 2, that's pretty much 1, right? But if this had been 2n, then the limit would have been half. Yes?
Okay, back to the algebra thing you said. Is this going to kill a kitten if I did the 1 plus 1 over n, 1 plus 2 over n as 1 plus 1 over n over 2 over n?
Okay, I don't know. Okay.
You don't know that's going to kill a kitten?
Ask me after class, okay?
Okay.
This converges if x minus 1, the absolute value, is less than 1. So what's your radius of convergence? It is 1, right? Does that make sense? Okay. Now, negative 1 less than x minus 1 less than 1, right? Which means x is in between what things? 0, yep, and 2. Okay, good to there? Okay, tricky things happen a little bit when you plug in your numbers. So I'll do it in a couple steps. When you plug in 0, I have negative 1 to the n. What else do I have?
Negative 1 and 10.
Over n plus 1.
Does that mean the top is always a positive 1?
It means the top is always a positive 1. Does that make sense, guys? So that's really 1 over n plus 1, right? Which is basically the harmonic series, isn't it? Let's see. She just wrote harmonic divergent, which means, because it's not exactly the harmonic series. The harmonic series is 1 over n. Does that make sense? So we're just going to say harmonic-ish, and this.
So would we have to do direct comparison tests on our homework?
No, on your test, I want you to just sort of give me the simplification and tell me if you had to use a test, what test you would use. Like the AST is super easy. It should usually be a p-series. You would have to actually use limit comparison, I think. I think the inequality won't go the right direction. So you would need to use LCT, but like it's pretty much the harmonic, like it just move on. The point was you recognized it as a harmonic, basically. I'll make sure that the people grading your homework know that and shouldn't be picky. How about at x equals 2? So then the difference is you get the sum n equals 0 to infinity. You have a negative 1 to the n, that's always there, right? Then you do 2 minus 1 to the n, which is just 1 to the n or 1, right? It's the sum n equals 0 to infinity, negative 1 to the n over n plus 1. This converges by the AST. And I think really, when I've graded this stuff in the past, I have just checked that students plug in the numbers and simplify correctly, make the right conclusion, and tell me what test they would use. Like, they're usually really easy applications of those tests. If you get something really weird and wacky, you probably made a mistake. Okay, like if you get some kind of crazy crap here that you can't immediately say this is the AST, it converges, or it's like a P-series basically, you did something wrong. Almost guaranteed. Okay? Other than there's a couple
Or they
hard.
hit us.
But usually it's a mistake, especially on a quiz or a test.
And the quiz or a test.
Yeah. Woo, this one. This is fun.
Do you use orbitalls?
No.
You can't derive.
No, you can't derivative factorials. Yeah,
That's terrible English, but yeah.
it is. All right. So the tricky thing here, you can get the right conclusion just by being lucky. So how about you try plugging in n plus 1 and like just writing down what you get, and then we'll talk about how they simplify, okay? But do the ratio test, start it, and just plug in your an plus 1 and an and see what happens.
I think factorials always pass in the exponentials, right?
Yeah.
So that should be okay. Keep trying to hit an X amount of minutes.
Yeah, I know, it's kind of a habit. You could be still thinking, but did everybody at some stage end up with x to the 3n plus 4, 3n plus 1 factorial over 3n plus 4 factorial? Yeah.
Couldn't you use that, the original as the 3 and plus 1, and then subtract it, so make it, like multiply it by, like subtract n plus 1 out of it? To make the n plus 1 subtract that?
I think you might just be a step ahead of me. Is that possible? Did you do more?
No, I was just saying, like, could you take the original
Original?
and be the n plus 1, and then...
If you take the original and make that the n plus 1, then the one you divide by has to be n minus 1. So it can theoretically work, but I wouldn't suggest doing it. I don't think it's actually any easier. Okay, so now how the cancellations are somewhat easy for the x's. Tell me how much x, what is the power that x is raised to if it's left? X cubed is in the top, right? So now the factorials are the tricky parts. In the top we have 3n plus 1 factorial. In the bottom is the bigger factorial. So you start with 3n plus 4 is your biggest number. What's 1 less than it? 3n plus 3, 3n plus 2, and then after that comes 3n plus 1 and everything down, which really is 3n plus 1 factorial. So this is one of those instances where you could get lucky and like not cancel correctly, but still get the same answer, and the grader will check if you have the correct expression before you take your limit. It does equal 0, yep. Absolute value of x cubed. Yeah, because 3n plus 4 times 3n plus, there's no need to actually multiply that out. I just kind of care that you can cancel factorials correctly because that is a little bit tricky.
Oh, I forgot to try my 3n plus 4.
But this is a constant and the denominator is going to infinity, right? So number divided by infinity makes 0. So this is, 0 is less than 1 always. So your radius of convergence is infinite, and your interval of convergence is all real numbers.
But you can have made that conclusion just by looking at it.
Exactly. And so actually, in many ways, the problems that you do that give you either an infinite radius or a radius of 0 are easier because there's no checking endpoints. Does that make sense? You don't have to plug any numbers in because there's no endpoints.
But I mean, like, if you just look at the top, you've told us before that an exponential will always increase slower than a factorial.
I think if it's the case, if you have x to a power over a factorial, I think that the radius is always 0. I'm pretty sure.
What do you mean radius is always infinite?
Yes, the result is always 0, the radius is infinite, yes. Okay, one last one, I think I've got for this. Do you see how this is 2x minus 1 instead of just x minus 1? And that kind of fusses with the radius a teensy bit. So you have to be a bit careful.
Divides it by 2, right?
Yeah. Oh. Jill changed her thing to a 3 to the n. I'm not sure why, but just to be consistent with her notes, let's make that 3 to the n. I think it works out either way, but so same way, start the limit, start the ratio test, plug your a(n plus 1 a(n over a(n), and just do that, okay? Because that part's not going to be different. So a(n) is 2x minus 1 to the n over 3 to the n root n. And I want you to try to work out this limit.
First one, this one. So plus 1. Plus 1. High potential for decades.
Limit's not so bad, though. Did everybody end up with 2x minus 1 root n over 3 root n plus 1? Okay, so I'm just going to take the 2x minus 1 and the 3 out of my limit. And then write that as root of big old thing, n over n plus 1. And that's not so bad. You could show more steps or not because this is so fast. The limit goes inside the root. Where does n over n plus 1 go? 1, right? So this thing goes to, this limit is 2x minus 1 all over 3, right? Is that okay? Okay. So this converges if the absolute value of 2x minus 1 over 3 is less than 1, which is 2x minus 1 absolute valued is less than 3. Is that part okay? Now the slightly tricky bit on this one is that 3 is not your radius of convergence. And the reason is because the radius of convergence thing, if you look back on that first page, it was x minus c less than r. That's like the form that you're in, so you can see the radius of convergence. So this isn't x minus a number, it's 2x minus a number. So
could you divide everything by 2?
divide it all by 2, exactly. So that would be x minus a half is less than 3/2. Okay, so you have to do that to get it in this form.
So
And there are not that many questions on the homework like that. Okay, I think there's like 2 examples in the book of this happening. Okay, it's not that frequent. Just be aware that that could be why you're getting your R wrong if WebAssign is doing some kind of funky randomizing on me. Like if it changes this number in front of there repeatedly, it's just gonna change your radius. So your R is 3/2. And if you don't see it there, you'll see it once we change and make our interval. Say that again? Oh, you said bless you, okay, yes. Thought that was a question. Obviously, I didn't hear you. Okay.
Could you have said 2x minus 1 is less than 3, greater than negative 3?
Yeah, we can do that. Do you guys see what he's saying?
Okay.
To get the numbers, we could say -3 less than 2x minus 1 less than 3, right?
Yeah, just make sure that would get you the same thing.
It will get you the same thing. Yep, you could use either one of them. Which means that -2 is less than 2x, which is less than 4, right? Which implies that x is in between what things? And, I'm sorry, I boo-booed. Look at, how wide is that interval from end to end? Width equals 3, and you know that the radius is always half the width, right? So the 3/2 does make sense, right? Okay. Now just test those endpoints. So at x equals -1.
Still just in the AST, right?
N equals 1 to infinity. So when you plug -1 into 2x minus 1, you get -3 over 3 to the n times root n.
I'm now seeing why she had 3 instead of 5.
Well, if that would have been 5, I'm pretty sure that, anyway, I don't know why she changed it, but we'll just go, there must have been a reason. -1.
We wouldn't have gotten 3.
But we would have gotten different radius as well, so I don't know if it matters. Okay. So do you buy that that's a simplification? So is this series going to converge or diverge, and by which test?
Why does it still have it to the end?
It still has a -1 to the n, right?
Oh, you just simplified the number down to...
Yeah, so what I did was these are both raised to the n power, right? I could make them one big thing to the n power.
And then
It becomes -1, right?
Yeah.
So this is an alternating series. Does it converge or diverge? It converges, yep. It's a convergent G. I mean, the P series officially have they're not alternating, but it kind of is like an alternating P series, and those definitely converge. Versus at what x equals 2 is our next number, right? We get the sum from n equals 1 to infinity, I think 3 to the n over 3 to the n root n,
Isn't it just 1 over root n?
which is 1 over root n.
Very divergent.
Yeah, that diverges. That's a P series. And P is equal to 1/2. So it's kind of just a nice review of the ratio test, right? And root test occasionally.